Hi, this is Professor Damn. We're going to go ahead and do a full example of a sample Z. So we have a full example to look at from start to finish for you to practice before your test. So let's go ahead and look at the story that I made up for this example. This says, pugs live an average of 12 years, give or take 1.8 years. 25 pugs were fed a raw diet and they lived an average of 13.2 years. Do the 6 steps to inferential statistics to see if a raw diet affects the lifespan of pugs. Alright, so let's get started. So remember, our first step is we need to restate the research question. And it's really already spelled out for you here in this last sentence. It says, see if a raw diet affects the lifespan of pugs. So if I wanted to turn that into a question, it would be, does a raw diet affect the lifespan of pugs? There we go. So then our second step is to establish the null and alternative hypotheses. So we're going to do just like we've done in class, where we take this research question and we turn it into a statement for the alternative. So how can I make the question, does a raw diet affect the lifespan of pugs, into a statement for the alternative? So hopefully you were thinking of the sentence, a raw diet affects the lifespan of pugs. Clearly I won't grade on handwriting. Now, how do I take this statement and make it appropriate for the null? Now remember, the null hypothesis is always about no difference. So what can I do to this statement to make it about no difference? We're going to add not. So we're going to say a raw diet does not affect the lifespan of pugs. I'll let you fill that in. All right, we're well on our way. Let's keep going. So for step 3, we have to define our rejection region. Now, I'm going to draw it because that's my favorite technique for defining my rejection region. But remember, I have to decide if it's one-tailed or two-tailed. So what I'm going to do is go up to my first step and look for my key words. Now, if I see keywords that say things like more, increase, improve, better, then I might be looking for a one-tailed test that's an upper tail. If I see words like decrease, worsen, fewer, then I might see a one-tailed test that's a lower tail test. But I see a word, and if you can read it, it says affect. That's a very generic phrase. It may mean that it might make the pugs live longer, or they might die sooner. So I'm trying to see if there's any effect at all. So that means it's two-tailed. So I'm going to denote two-tailed down here by shading in my regions. I'm going to go ahead and label that as my rejection region so that I know it's clear what I'm drawing there. I'm going to go ahead and put my rejection numbers in there, my critical values. Remember, if it's two-tailed, it's 1.96 and negative 1.96. If we were using a one-tailed test, we'd be saying 1.65 or a negative 1.65 depending on the tail. All right, so we are already at step 3. Now we're going to do step 4. Step 4 is where the math looks a little different than what we've been seeing because the individual z had fewer numbers. But let's go ahead and set up our formula. Remember, it is x bar minus mu divided by sigma divided by the square root of n. Don't forget the square root. A lot of students forget the square root. So let's talk about what these are, because we're going to have to go find them in the story. X bar is our sample mean. Remember, mu is our population mean. So in the individual z, we were just looking at x minus mu, but now we're going to be looking at a sample mean. So I want to look at the story up here and find something that's telling me it's the mean of the sample. So if I'm looking at this story, I see there was a sample of 25 pugs that were given a special raw diet and they lived an average of 13.2 years. So that means my x bar is 13.2. So if I come down here, my x bar is going to be 13.2. Now I have to find my mu and sigma. So these are the population parameters. So if I'm looking up here, I actually don't see anything that says mu is this, or population is this. But I do see a sentence that says pugs live an average of 12 years. So I'm saying very generically, pugs everywhere live an average of 12 years. So that is your population term. So there we see mu is 12, and my standard deviation, the give or take, is 1.8. So if I plug that in down here, 1.8 is my sigma. Now I have to find my sample size. Remember, we saw that up here as being the 25 pugs who were fed the special diet. So here, n, my sample size, is 25. Now, many mistakes happen when students start to solve this because they don't follow the rules of order of operations. So we're going to go ahead and solve this in steps. So 13.2 minus 12 is 1.2. I know the square root of 25 is 5, so it's going to be 1.8 divided by 5. Let's go ahead and solve the numerator first. I know this number is 0.36, so maybe I'll wrap down here. I have 1.2 divided by 0.36. And that number, I already calculated in case those of you are wondering how I could do this math so fast, is 3.33. So now I know the sample of pugs have a z-score of 3.33. If I put this number up in my picture, I know that 3.33 is up in here. That helps me decide what to do in step 5. I'm going to go ahead and put step 5 over here. So remember, in step 5, I decide if I want to reject the null or fail to reject the null. So the way the rules work is if it's in the rejection region, we reject the null. That's why we call it the rejection region. If it's in this white zone in between, we fail to reject the null. And then here's another reject the null region. So my 3.33 is clearly in my rejection region. So my answer for step 5 is reject the null. So I'm going to be dramatic and go up here and reject that null. I reject you, null. Cross it off. So now I'm left with this interpretation. So for step 6, I'm going to say raw diet affects lifespan of pugs. But if I were to call my grandmother and say, Grandma, I rejected the null today and found that the raw diet affects the lifespan of pugs, my grandmother, who loves pugs, is going to want to know what the answer was. So we might as well follow up and tell her, Grandma, the pugs live longer on a raw diet compared to those with a regular diet. All right, so what we have here is a full sample Z. You'll see that it's not that different from what we did with an individual Z. We have a similar kind of story. The only difference now is I have 25 pugs in my story instead of just a single pug. I now have to differentiate between the mean of the sample and the mean of the population. That's kind of the hardest part. But after we've been able to figure out those numbers, all the steps really remain the same from what we've done already. Just step 4 got a little different when we had to divide by the square root of n. So don't forget that step, but otherwise you have just completed a sample Z from start to finish. Congratulations, I will see you on Monday.